Okay, now this is the last kind of factoring, yet you would have to know how to do. So with three terms, we do the GCF, see if we have a difference of perfect squares. With three terms, we do the GCF, and see if we can factor the trinomial with that t-chart. Now, there needs to be a second power on that 7 right there. Now with four terms, here's what you're going to do, okay? You're not going to make a bunch of boxes, okay? That's the difference between four terms. Okay, so the first thing, I put an implied 1 in front of the first term. But I check quick for the GCF, okay? 1, 7, 9, 63 would just be 1. And then there's at the end doesn't have an x. So the GCF, just forget it. Now with four-term factoring, you use what's called grouping, okay? Now there's a way to set this up so you don't drive yourself nuts. You're going to make two parentheses plus each other with a plus sign. Then you're going to do the same thing, but you're going to put little spaces out there because you're going to be pulling some factors outside. And then finally, you're going to make a big line and a parentheses, and you're going to put a little parentheses on that line, okay? And that's how that's going to be set up. Now, here's what we do first. We put 1x to the third plus 7x to the second. And then here we're going to put negative 9x minus 63. All right, so first thing I look at, 1 and 7 are only in the first row on a multiplication table. Okay, so 1 would be the GCF. Now, look at both of them have x, so we take the last x to the second. We're going to put that down here, so 1x to the second. Now, over in this other one, I'm going to determine what the greatest common factor is out of 9 and 63. Okay, if you have to get your multiplication chart, you might want that. Okay, it's important you get the highest common factor, not just any common factor. Okay, so if I look at the row of 9, okay, the furthest row down, 63 is also in that row, okay, so 9 and 63. So, 9, okay, now you're not going to put x because the last number doesn't have x, okay, so that's important to understand. Also, the leading number is negative, so the 9s are going to be negative. So here's what you do with those. You put 1x to the second out here, and you're going to factor negative 9 out of there. Now these parentheses in this should be the same. Okay? So 1 divided by 1 is 1. Now when I divide an x third by an x second, that becomes just regular x. It'd be 3 minus 2, which is 1. It'd be x to first, okay? But we don't usually put first powers on x's. Then plus 7, and we cancel the x's there. Now over here, that's going to be negative 9 divided by negative 9 is 1x, and then negative 63 divided by negative 9 is plus 7. Okay? Now those are the same. Now here's what I do in the last step, okay, for the grouping. 1x plus 7 is in both parentheses. I am going to put 1x plus 7 in this right here, and then we're going to cross those out, okay? Because it's like I'm factoring it outside. Because, see, here's the plus, and don't make these circles. This is just me making a point, okay? What's common to both of those, okay? 1x plus 7, so I put that outside. And then I'm left with the 1x to the second and the negative 9. So I put 1x to the second minus 9. Now, you're going to go put that 1x plus 7. There's no more power on that x, okay? It's just... Now this one here, you got to check to see if you can do a dops out of that, okay? By the way, I would just ignore the 1, okay? Because x times x and 3 times 3, okay? This is me checking for a dops. So that goes x, and then that is 3 times 3. I don't put the I because we had a minus sign, okay? And then I go put these over here. So x plus 3, x minus 3. Okay, now if you want to get rid of that 1, you can keep it. It's up to you. Now it's factored. Now, to illustrate why this works, you don't have to write this out. But if I take those three factors, okay, those three factors, and I find their product. I would start with these two because they're conjugates. One's plus, one's minus. So I'd take x times x, and you see what I'm multiplying by. I'm doing the rainbows, okay? I get x squared, negative 3x, but then positive 3x. So those go bye-bye, and I have x second minus 9, okay? So this became x second minus 9, and that x plus 7, okay? I drop down, and now I FOIL that. So I go x times x second, x times negative 9, 7 times x second, 7 times negative 9, okay? So I end up with x times x squared is x to the third, negative 9x, 7 with x to the second, negative 63. None of these can be combined because that's a third, that's a x, that's a second power, and that's a constant. So I'd have x to the third plus the 7x to the second minus 9x minus 63. Now you don't have to do all that. Okay, so next one, I need to factor that. So it's 4 terms. I can see the 4 terms right there. GCF I usually don't do on 4 terms because 99.99% of the time it's just 1, okay? Yep, that one's no different. And you have the x constant at the end. So you go to your grouping with 4 terms. 4 terms is almost you set up your grouping. So you line up your, you're going to set a sum of 2 parentheses, and then the same thing, but you're going to have little spaces outside, and then a space and a parentheses. Now I'm ready to roll. 1x to the third minus 2x to the second, and then negative 16x plus 32. So 1 and 2 have a GCF of 1, okay? But these both have x, so I take the x that's at the end, which is to the second. Now over here, 16 and 32, the lowest row down there is 16, okay? That's why I kept telling you it's got to be the furthest row down. So 16. Now you're not going to put an x because the number at the end doesn't have x. But you are going to make your 16 negative. So I factor out 1x to the second, and I factor out negative 16. I would personally, if I were you, just get rid of the 1 at that point, okay? There's no point in having it there anymore. 1 divided by 1 is 1. Now taking x third divided by an x second just gives me x. And then minus 2, and we always cross out the x's on the final division. Now the other one's going to be the same thing because that's 1, that's x, and that's going to be negative 2. Okay, now look at your 2 parentheses. They're exactly the same. So and by the way, make that a longer line with a smaller parentheses. So in that smaller parentheses, you're going to put 1x minus 2. Okay, then in the larger parentheses, I put my outside factors together. X to the second minus 16. Now, there's no power on that one, so that one is part of my final factorization. This one right here, I check for a difference of perfect squares. Okay, I'm going to write a little DOPS question mark. And that's x times x, and that's 4 times 4. So it'd be x, 4 and 4, and I have a minus, so it's a traditional DOPS, a normal DOPS, so I don't put the i's on. So this comes over here, and then this factors into x plus 4 times x minus 4. It's a new type of factoring. You're usually going to end up with 3 parentheses. Okay, so I put the 1 in front. Okay, GCF is 1. Okay, they're almost always 1. I don't really put 4 term factoring with a GCF. So I write the word grouping. Write that word so you remember what it's called. And groupings when you set up parentheses plus parentheses. Then the same thing with spaces outside. And then a space, a big space with a little tiny parentheses. And then a bigger space. Don't put any sign between those at the end. That's the setup, okay? So I put 1x third plus 4x to the second. And I put negative 9x minus 36. So 1 and 4 is just a 1 GCF, but they do have both x's, so I take the x at the end. Okay. 9 and 36 are in the 9th row together, so 9 is the greatest common factor. We're not going to put x on the 9 because 36 at the end is a constant. It has no x. And then negative, negative. So I'm going to factor 1x to the second out because that's what I'm dividing by, and then I'm going to factor negative 9 out of there. Kind of like I do with the GCFs. So that becomes a 1, and that becomes x. And then plus 4, those cancel. Remember not to put the x there. If you're dividing x's that have the same power, you get rid of them. That's going to be 1, the x, and then negative 36 divided by negative 9 is positive 4 as well. So compare your two parentheses, and they're the same. If they're the same, you can fill this out with 1x plus 4. And cross those out, and in this one, you kind of make that one expression, 1x to the second minus 9. At this point, I would get rid of the 1 there. That doesn't serve a purpose anymore. Now the x has no power there, so that is now factored into simplest form. But this still has an x to the second, so there's a potential for that to have adopts. Okay, so be looking for that. So that's xx, and that's 3, 3. The minus makes it a traditional dops where I don't have to use the i's. So I put x plus 3, x minus 3. Okay. Okay, last one. Okay, 4 terms. GCF out of the 4 would be 1. You couldn't do an x because you have a constant in the expression. So grouping. So first I group these two with these two. And then I'm going to, see now I'm ready. If I have the game plan set up, the rest is pretty academic. It's like the other ones. You made your boxes, you were set. Well, if you make the grouping diagram, you're set. So you got 1x to the third, minus 3x second. You group those, then you group the 6x is plus this time, and you group those. Okay, 1 and 3 is 1, but they both have x's, so I take the x at the end along with the 1. 6 and 18, that's in the 6th row, okay? So I factor out 1x to the second, quick get rid of the 1. If it's a 1, if it's another number, you don't get rid of it, okay? Okay, and that's going to be 1, and that's going to be x minus 3. Those can cross out. Okay, and that's going to be 1x minus 3. All right, so now that I have that established, I compare the two parentheses, and they have the exact same expression inside. So I can put 1x minus 3 in the little parentheses. And then the big one, we put our x to the second and add 6. Now I know the 1x minus 3 stays the way it is. That's in simplest form. Now this might not be because there's a second power. And you're looking for dops, okay? Difference of perfect squares. So x to the second is x times x. 6 is not a perfect square. No, it's not 3 times 3. That's 9. 6 is not a perfect square, so we're just going to carry this down here, and that's factored. So not all the time do we end up with 3 parentheses. Sometimes there's just 2.